SNS College of Technology, Department of Artificial Intelligence and Data Science, Principles of Operating Systems. This session, we will be having a detailed discussion on the concept paging in operating system. Paging. Paging is a division of the logical memory into blocks of the same size. And the same, which is being done in the physical memory part, is called as the frames. That is, dividing the physical memory into fixed size blocks is called as frames. And the size of this particular frame or the pages is going to be to the power of 2, ranges from 512 bytes to 16 megabytes. And we need to have to track to keep these free frames which are available. And to run a program of a size n pages, we need to have equal number of free frames of the same size as the page, and the program is being loaded into the memory. And a page table is there which will be doing the action of translating the logical address to the physical address. So a logical address is the address representation at the page size, that is at the CPU end, wherein a physical address is the address representation at the memory side. The backing store, like splitting it into pages, is done, and this particular type of a paging concept also goes with a problem called as internal fragmentation. The address translation scheme. Here, we are supposed to find out the correct address that is being generated by the CPU in order to map it to the frames at the memory end. So address generated by the CPU is divided into two broad type, that is going to be the page number P, and next is the offset D. So the page number P is used as an index into the page table, which contains the base address of each page in the physical memory. And the offset is going to be the combination of the base address to define the physical address that is sent to the memory unit. So a page number plus an offset will give you the actual logical address at the CPU end. So the pictorial representation defines clearly the page number P and the offset D. And so for any given logical address space for the 2 power m and page size 2 power n, we have the page number P as m minus n and the page offset D as n itself. Now, let us see the address translation. First step, we are going to break down the logical address. In our example here, we have taken the logical address as 2050 bytes and the page size here is 1024 bytes. Now, when we calculate this particular logical address, it is now split up into two page numbers with an offset of 2 bytes. That means it spreads to the next page number with 2 bytes being occupied in the third page. The second step here is the page table. Now, the page table here maps the page number with the frame number. That is, it maps the logical address to the physical address part. Now, the page number here we have calculated is 2, and it is now mapped here to frame number 8. So, 2 page number is now linked with the frame number 8. The next step here is the physical address formation. The frame number 8 is being taken up at the physical address part, that is the memory side, and the offset of 2 is being added to it. Now the final calculation here becomes frame number, that is 8, and the page size is 1024, because we know that each of the frame is going to have the same size as the page number. So each page size here is 1024 bytes. So the frame size is also 1024 bytes. The frame number is 8 multiplied by the page size, that is 1024, and our offset is 2, and we get the physical address as 8194. So this is how we do the address transfer. Now let us see how an internal fragmentation can be calculated. In our example here, We had considered the page size as 2048 bytes and the process size here is 72,766 bytes. Now, dividing 72,766 by 2048, we get a value as 35 pages plus an offset of 1086 byte. The internal fragmentation now here is out of the 2048, which is a page size, when we lessen the value 1086, we get an answer as 962 bytes, which is going to be a internal fragmentation. That means a space which goes of no use in our memory. So a worst case fragmentation is something where we have one frame just spending up 1 byte as a wastage. That means that particular memory size goes of no use. And internal fragmentation makes up a non-usage of a memory within the allocated size of a page or a frame. So in this discussion, we have seen what is paging, how does an address translation takes place, that is transferring a content from a CPU part, the logical address region, to a memory side, that is a physical address part. And then we had also seen what is an internal fragmentation and how does an internal fragmentation occurs in paging. Thank you.